All right, good morning class. And so today we're going to be talking about different division algorithms. In particular, we're going to be working through a partitive division problem using the standard algorithm. And so our partitive word problem is that Kayla is making 546 cupcakes for her friend's birthday party, and she wants to split the cupcakes evenly among two friends. So how many cupcakes will each friend receive? So this is a partitive division problem because the divisor represents how many groups there are instead of the amount in each group. So we know that there are two friends and we want to find out how many cupcakes each friend will receive. So I have my dividend here and my divisor here, and then we are looking for the quotient, which is also known as the answer. And so we're going to use the division bar to set this up because that's what the US standard algorithm uses. So we're going to draw our bar, we're going to put the dividend on the inside, and then we're going to put the divisor on the outside, on the left-hand side. And we're going to walk through this using the standard method, but also using the base 10 blocks. So for the base 10 blocks, we're going to represent 546 using base 10 blocks. And to represent that, we're going to use something called a flat, which represents 100. We're going to use a long, which represents 10, and a unit, which represents 1. And so these are our different units of measure. And so we have 546 cupcakes, so we're going to represent that using these blocks. So we're going to have 5 100 blocks to represent the 500 in this place value. Then we're going to have 4 tens, 1, 2, 3, 4, to represent the 40 and 546. And then we're going to have 6 little units to represent the 6 ones and 546. And so to start off, I'm going to come over here at my standard algorithm side, and I'm going to ask myself, how many times can 2 go into 500? And so 2 can go into 500, or 5, 2 times. And 2 times 2 is 4. 2 times 2 is 4, so you write the 4 there. This becomes a subtraction problem. And so 5 minus 4 is 1. Then we're going to regroup, bring down the 4. Then I'm going to come over here, and I'm going to create 2 groups. 1, 2. I'm going to make that first one a little bit bigger. So this represents the divisor, 2 groups, and the dividend is represented by our base 10 blocks. So we're trying to fit 546 into 2. So we want to know how many times it can fit in. 546 can fit into 2. So we're first going to look at the hundreds, so we're going to ignore this. And we have 5 hundreds. So we know we're going to put, I'm going to use a different color to represent this. So we're going to put a flat, or 100, in each container until we aren't able to evenly distribute them. So we have 1, cross that off, 2, cross it off, 3, 4, and we only have 1 remaining in 2 groups. So I'm going to circle this, and that is going to be split into 10 longs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're able to evenly distribute them among the 2 groups because 1 does not go into 2. So then we're going to come back over here, and we have how many times can 14 tens go into 2? And so 14 tens can go into 2 7 times, because 7 times 2 is 14. It's 14. So we're going to make a subtraction problem. That's 0. So we're going to pause here, and we're going to come back over here. And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 tens, which is represented right here. And we're going to evenly distribute that among 2 groups. And so we said that there could be 7 tens in each group. So we're going to put 7 in each group. 7 cross 2. Like so. And one more. So 1, 2, 3, 4, 5, 6, 7 tens in each group, which is represented, like I said before, right there. And so now we're going to regroup the 6. We're going to bring the 6 all the way down, like so. And 6 is represented by the 1s. So we have 6 ones over here, and we're trying to fit it into the 2 groups. So we know that 6 divided by 2 is 3, or 2 goes into 6 3 times. So the 3 is going to be put up there. 3 times 2 is 6. All right, subtract the 6, which means we have a remainder of 0. And I'm going to represent this by placing the 6 units into the 2 different groups evenly. So we're going to do 1, 2, 1, 2, 1, 2, 1, 2. Then we have 2 left over. 1, 2. All right, and so we have 2 100s. 1, 2, 3, 4, 5, 6, 7, 7 tens, and 3 1s. So if you add 200 plus 7 times 10, which is 70, and 3 times 1, which is 3. If you add that up, 3 plus 0 is 3. 0 plus 7 is 7, and 2, bring down the 2. You have 273. And so, like I said over here, 273 can go into 546 twice, which was represented in the US standard algorithm, and which is also represented in the base 10.